Hello guys, what's up? Welcome to my channel Study Circle. Have a fresh and energetic session. So in the last video we have saw the circular motion and the centripetal force and the terms related to it. Now in this video we are going to discuss the Kepler's three laws. So Kepler is one of the scientists who has observed the planetary system, how the planets are revolving around the sun and which kind of forces they are possessing. Now he has observed the things, then what is the behavior of these planets with respect to the sun, and on the basis of these he has given three laws which are known as the Kepler's three laws. So one by one we are going to learn those laws, but before that you have to observe the diagram 1.4, the orbit of a planet moving around the sun. So in this diagram you can see the A, B, C, D, E, F are the planets. You can consider those are the planets, or you can consider, for the second law, you can consider planet A, C, E as a single planets. So point S is denoted as the sun, which is colored with the red color, and point A, B, C, D are the planets which are revolving around the sun. So in the first law he has stated that the orbit of a planet is an ellipse which the sun at one of the foci. What he has stated, I will repeat the law. The orbit of a planet is an ellipse with the sun at one of the foci. So this is what the first law stated by the Kepler. But one thing we have to consider, that why we have considered the foci here, because we are not considering the circle, and the circle possesses the center. So here is the ellipse, so the center of the ellipse is termed as the foci. So this is what he has explained in the first law. So as far as the second law of Kepler is concerned, he states that the line joining the planet and the sun sweeps equal area in equal interval of time. What he has stated? He stated that the line joining the planet and the sun sweeps equal area in equal interval of time. So we will move toward the diagram now. Suppose we have already considered that the sun is at the foci and planet A, C, E are the planets which are revolving in an orbit. So suppose T is the time required to move point A to point B, and at the same time the point C will also move up to the point D, and they will possess the same time for this movement. So this is the law given by the Kepler. I will explain one more time. Suppose line joining the planet means A and S, or SA is the line which is joined by the sun to the orbit, that is AS is the line joining the planet, sweeps equal area, means A to B will sweep equal area and the time required for it is T. At the same time the C will move up to the point B and it will also sweep the equal area in equal interval of time. So this is the second law given by the Kepler. Now we will see the third law of Kepler, which states as the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of the planet from the sun. What he has said, the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. So suppose we consider that T is the period of revolution and R is the distance of any particular planet from the sun. So then there will be, according to the third law of Kepler, T square is directly proportional to the R cube, means the square of time period, means as we have denoted the time period with the letter T, so there will be T square around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Cube of what we have considered as the distance, we have denoted the distance of planet from the sun as with the letter R, so there will be cube of that R. So T square will be directly proportional to the R cube, and if we want to remove the proportionality sign, we have to give it as the T square upon R cube direct is equal to constant k. T square upon r cube is equal to constant k. So these are the three laws we have discussed, which has been given by the Kepler. So one more instruction I would like to tell you here, that whenever you are going to state the laws in the exam, you have to write in the way, if they ask write down the Kepler's first law, then you have to write in the way that first of all you have to write the Kepler's first law states that, or the Kepler's second law states that, or the Kepler's third law states that. After that comma, after that double inverted comma, the orbit of a planet is an ellipse with the sun at one of the foci. So this is the statement. After the statement you have to give the full stop and complete the double inverted comma. So in this way you have to complete your law and you have to state the law in the exam. So the examiner will give you the out of out marks. So this question has been asked in 2017 2018. So this is one of the important article or the important point from the exam perspective. So this is the Kepler's laws. So this was all about for this video. Now the next part of the chapter we will see in the next video. Thank you so much.